This conference will now be recorded.
So guys, we'll start with something known as graph data structure for the day, where we'll take two different use cases. The first use case will focus on undirected graph. We'll see how the Facebook has a use case, as in when you send a request to some of the users, so how you guys get connected to each other, right? So the other use case will be for the directed graph, where we are going to kind of replicate Instagram. So it's like where you follow someone, right? So there is a single direction, there is not the bi-directional or the case of undirected structure. So let's see what we did in our previous session. So in our last session, we wrote this graph data structure with the vertices and then the adjacency list, right? So today also we're going to do certain similar thing, but you can see a bit different programmatical approach, right? So let's see session number 31, a new Python file, session 31. So first of all, I'm going to write this undirected graph, which is going to follow the use case of nodes which are connected to each other via edges, and we have already done this part. If you can see this reference as an example, right? So this is the kind of your undirected graph where nodes are connected to each other, where vertices are connected to each other via these edges, and edges, they are not representing any direction. So we'll take the Facebook case study here. I mean Facebook use case, not the case study. So I'll create a class called user. So for any user will have certain attributes. So let the user register to the Facebook. So I'm gonna have the name of a user, let's say a phone number and email, and this user is going to act as a node for us, right? So user in graph data structure is one of the vertices slash nodes in graph. So you say self.name is name. Then I'm gonna take this phone number and the last one as the email. So these are the user details, and if you wanna see the user details, I'm gonna say show user and print down the data in this format here. So self.name, phone, and the email. Right, so this is your basic user object, as in when we'll get connected to the Facebook, right? So these are some basic details we register on, right? So let us have a main function. So what I'm gonna do in my main function is register some users, right? So let us say create some user objects, and I'm gonna do this by saying user one is your user object with the details as in name, phone, and email, right? So let us say that this is your very first user. So I'm just giving one kind of a number here. So other than that, we can just give a UID, right? So we can have this UID coming in. So I'm going to give this UID 1, and here also I'm just going to put it in this manner, self.UID, right? So 4 attributes instead of 3. So there has to be a name. Let's say the name is John, and we have a phone number with the John. Then you got this email, john@example.com, right? So this is the user 1. So same way, I'll have some more users. So just give me a moment. So let's say 3, 4, 5, 6. It's more than enough, right? So there are 6 users available with us. So let's put in some data for them. So you got John, Jenny, Fiona, Dave, let's say Kia, and Leo. Some phone numbers. So we got these objects created, right? These are all the user objects which are created over here in our program. So we are considering that they are going to register, right? So these are the kind of users who are going to register. Now there is this class called Facebook. So you're going to consider this Facebook over here as graph, right? So consider as graph data structure. So what do we have a graph, right? So guys, graph is a collection of vertices. That's like your nodes and the edges, right? So I'm considering this user as a node here. So we'll define the constructor first of all, right? In the constructor, what I'm gonna do is I'm gonna write this self dot nodes is a dictionary. So I'm using this built-in data structure dictionary. So nodes or vertices, right? It's up to you. So however the way you want to define it, so it's up to you, right? So this nodes or the vertices is this terminology, right? So Facebook is going to have this attribute called nodes as dictionary now, right? Now the next thing which I'm going to do is define this function called add, let's say connect user. So when I have to connect user, since Facebook is going to work as an undirected graph, right? So we will add both users to each other's adjacency list, right? So let's see how you can work it. So I'll say connect the user. So there may be some user 1 and user 2, right? So who are going to connect in the graph. Now what I will do next is, so this nodes over here is going to be number of users. I can take the terminology as number of users, right? So we'll just see how this is also replicated as graph. So what I'm saying is that there is some class called graph, right? So you got these vertices as a dictionary, and this is your vertex 1 and a vertex 2, right? So I'm just following the same terminology at the edge. So something like this, right? We are trying to create as in this below class called Facebook. So I'm writing this function connect user where I'm going to check if u1 not in self dot users. In case u1 as a key is not there in this dictionary, then you create a key. So I'll say self dot users of u1, you create a key, and you say that this key will have a list. So in case u1 as a user who is going to connect to some other user, if it is not there in this users, which is a dictionary, a key value pair, so you create this key called u1 in the users dictionary, and the value of this dictionary is going to be an empty list. So the other way around, I can say if u2 not in self dot users, so self dot users of U2 is also going to be a list. So we are checking if users exist as key in dictionary or not. So if not, add the key and let the value be a list, which is kind of you can say a friend list. So can I get a smiley from all of you as of now? Are we good to go, guys? What we have done so far? You can please raise your queries or concerns in case you have here. So U1 and U2, we are going to add these users basically, Lavish, right? So U1 and U2, they are the two users. So coming up here, I'll just say print. So Facebook graph created, right? So the moment you create this Facebook graph, so what is there in the users, right? So I'll say print users as of now, comma self dot users, comma I can see size, comma length of self dot users. So now for an instance, I'm going to come here and say graph is Facebook. So you created the object of Facebook, right? And what we did, we just let's just execute the code as of now. So Facebook graph created. So users as of now, it's an empty dictionary with the size as 0, right? So I'll say graph dot connect the user. So we got these few users, right? User 1, let's say user 1 would like to get connected to user 2. So I will say user 1 comma user 2. So these two users would like to connect. So we said graph dot connect the user 1 and 2. Now what's gonna happen here? So U1 not in the self dot users. That is true. This user 1 is not there in the dictionary. Dictionary is empty. So you create a user U1 in the dictionary, right, with an empty list. So in case you would like to print this user list in your Facebook graph here, so I can just say define print users, and I'm going to say print me self dot users, and then I will say print total users, comma length of self dot users. So let's come here and now say graph dot print the users. So when you run the program, so what you see is now we have these two user objects. So these objects are serving as hash codes, right? Their hash codes basically are the keys. So these are the keys of your dictionary called user, and the list is empty. So every user is going to have an empty list. So this list is kind of a friend list, or in our previous discussion, this was an adjacency list, right? So coming here, in the add edge, what you are doing is the same story like this. So instead of U1, you got this V1. So the normal graph, right? So you got this self dot vertices. It's the same terminology. So you say self dot vertices of V1. So V2, right? So this is the same use case. But this connect user is as of now not complete. So the next thing which I'm going to do is your self dot users. So I'll say users of V1. Sorry, this is U1 for the terminology. Dot append the guy U2. and self.users of u2 append u1. So what I did, I added u2 in the adjacency or the friend list of u1 and u1 into the friend list of u2. Guys, can I get a smiley as an acknowledgement here? So add the users in the friend list. So every user is going to have their own friend list, and this friend list is nothing but this is the agency list for the users. Exactly same thing which we did in our previous session, right? So in the previous session we were maintaining it in a bit different way. So what we had is we had some nodes from 0 to n minus 1, right? So vertices were 0, 1, 2, 3 as an index. So today we don't have the vertices, we have the objects as vertices, and their adjacency list is going to be maintained for us, right? So you're connecting the user instead of saying add edge. So guys, acknowledgement awaited from all of you as a smiley in case we are clear till here. Now for instance, I am connecting this user 1 with the user 2, right? So let us say we have some more connections to be done. We'll connect user 1 with the user 3, let's say 2 with the 4, and then coming up 3 with the 4, let's say 3 is also connected to 5, and 4 is connected to 5, and 5 is connected to 6. So this is how you are trying to do the connections with your various users, right? So 1 is connected to 2, 1 is connected to 3, 2 is to 4, then 3 is connected to 4, 3 is also uh, 3 is connected to 4, 3 is connected to 5, 4 to 5, and 5 to 6. So these are the kind of connections which we are making. Now since it's a kind of a graph, so we need to print every user and every friend list for this kind of connection which we have made. But before that, let us print all the users, right? So what we see that there are total users as in 6. That is true that we created 6 user objects. So this is the key having a value as a list. If you see now, it contains 2 hash codes because user 1's adjacency list will be user 2 and user 3. User 2 same way, user 3, 4, so on and so forth. You got this dictionary with the keys as users and their list as the adjacency list. So lastly, let us write the function called print Facebook, and now I'm gonna print everything available in this data structure called Facebook, right? So we have these users, we are printing the users, but I want to print the kind of Facebook, all the users with all their friend lists, right? That is what I'm gonna print, right? Or I can say print users with friend list. So in order to do this, first of all, let's get the keys from your self dot users dot keys, right? You get all the keys of the dictionary. Fetch all the keys from dictionary. Now you iterate in this key, right? So for key in keys, so every key, so it's a user object, right? So every key is going to act as a user object. So I'm gonna say print key dot. So we have this user called show user, right? So I'll just say key dot show the user, but I'm gonna make this user to be, let's just not say show user. So I'll just say get the user details, right? So I'll just return rather than the printing. So we'll return the data rather than printing over here. So I'll print it here. So I'll say print key dot get the user details, right? So you fetch the user details and you print it. So I'll just say end with so I'm printing in the same line, right? So I'll just put this hash over here in the end part. Now I will say friend list. So friend list is going to be what, right? It's going to be your self dot users of key. So you get the entire list and now you print down the list, right? So for a friend in the friend list, I'll say print friend dot get the user details, and I'll say with the end coming up as let's put some pattern like this. All right, so this is the kind of a pattern which I will use to discriminate between the friends. So let's come here and say, so this is graph dot printing the users. Let's use an empty print here, and I'm gonna say graph dot print the users with the friend list. Let's try to run the program and see what's gonna happen for us. Okay, I think let me do something here and there. So just give me a moment. So forgot to execute this method. Instead, we just printed the hash code. So here we are, guys. And yes, after this for loop finishes, I'll do an empty print line so that we have the data at the other line. So you got the first friend John, I mean the first user John, and John is going to have this. So I'll just come here and say print friend list. So just give me a moment. So I'm just trying to make it in a more better way. Okay, so here we are with the first user John, and what you see is John details. So John's friend list is Jenny and this Fiona 1 and 3. So what I can do is I can even leave this and I can just print in a new line only. So this is John's friend list, Jenny and Fiona. And if you'll see, we made the user 1 connected to 2 and user 1 connected to 3. So John is friends with Jenny and Fiona. Next is Jenny. So Jenny is having two friends in the list, John and Dave. So user 1 was connected to 2. So hence you got this guy John, and user 2 is connected to user 4. So number 3, user 1 is connected to user 3. So is user 3 connected to user 1. Moving ahead, user 3 is connected to 4 and 5. So you got this 4 and 5, Dave and Kia, so on and so forth. So guys, can I get a smiley from all of you? Did we understand what we did so far? So I'll share the code over the chat. So please give a small review and let me know in case you understood the structure. So the graph data structure is not that complicated, is not that challenging at the same time. So you just need to follow what we have to implement and how we have to implement it. So the same program can be replicated for Instagram use case. So let's say a new Python file, session number 31A. So if you have to follow the Instagram case study, then Instagram is a use case which followed this directed graph for us. right? So saved user, same structure. Let the class name be Instagram. So in the Instagram graph, what we have is when you will make the users to connect to each other. So you are adding U2 into the U1, but not the other way around, right? So if you see a small difference, right? It's a very small difference, a minimal difference. So in the session number 31, you are adding the users in the agency list, that is friend list of each other. But in Instagram, you have followers, right? So add the user in the agency list slash friend list of another. We are kind of replicating followers on Instagram of a user. So instead of the function name saying connect user, what I'm gonna do is I'm gonna say a follow user, right? So instead of this term called friend list, so this term becomes followers list. So that's the only kind of a difference for us. So guys, can I get a smiley from all of you till here? Are we good to go? So now what I'm gonna do next is, so these are the same structures for us. You got this Instagram. So graph is referencing to the object of Instagram. Instead of saying connect user, we say follow the user. So let us say graph dot print users, and I have this print users with followers list, right? One very small change here. So I'm just changing these basic terminologies here and there. So here we are. So for John, we got Jenny and Fiona as followers. For Jenny, you got Dave as follower. So for Fiona, we got Dave and Kia. For Dave, it's Kia. For Kia, it's Leo, and for Leo, there is none, right? So it's how the kind of directed graph works when it comes to your use cases. I hope it is clear. Okay, so there is a query from Prabdeep. So do we need line number 48 and 49? Yes, Prabdeep, you will need this in a way. So since, yes, you can even ignore this for this purpose, right? For this part of it, we can ignore it, right? So you can ignore this line number 48 and 49. This can work for us. Since you are following the undirected graph, sorry, directed graph, so this can be ignored. So I hope this part is clear to everyone, guys. Are we clear till here? Anyone finding any challenge? So I'm just sharing the code over the chat window once again. So Navnoor, in the print users function, what we are doing is we are just printing the list of users, right? So these users are what? They are the objects, and when you print them, they will there will be the hash codes, right? So when I'm saying this print users, graph dot print users here, it's just gonna give me the dictionary where key is the hash code of the user and the value is the list of followers. So same goes in the Facebook. It's exactly same, right? Exactly same. Okay, so you mean to say print users with friend list you're talking, right? Not the print users. You're talking about print users with the friend list. Is this the query? All right. So what we did, we first of all fetched all the keys from the dictionary since users was the dictionary, right? So every key further contains a list. So I say self.users of key, you get the friend list and you iterate in the friend list to display the data. So what is happening here, right? So you are creating a dictionary. So you create a key U1 in the dictionary and an empty list. Later you append U2 in the empty list. Good to go now. So what is this loop in the loop doing? Wonderful. So guys, let me push this code on the GitHub. So directional and undirectional graphs, Facebook and Instagram. So what I want you guys to do is just try adding a function called accept or reject request and see if your graph data structure works up well with them, right? So just writing on the chat box. So accept and reject functions in the user object. So try simulating the same features. So this is all for the day, right? And I have shared this program over the GitHub. So tomorrow we're gonna explore what is meant by breadth first search and the depth first search or the traversal of the trees. So we're gonna explore these two of the algorithm, and we're gonna even come up on something known as directed graphs after that, right? So tomorrow's session will focus on the two algorithms BFS and DFS, and later we'll understand how we can write a directed graph. So this will be all, guys. Thank you so very much. So have a wonderful time ahead. Bye guys, thank you.